Okay, one of the SOLs is very specific to this slide right here, okay, and that is to understand the powers of I, the exponents of I. When you raise I to the first power, obviously you have I. If you square I, you know, again, if I is defined as the square root of -1, then if you square both sides, then I squared equals -1. It has to be. Okay. Now, if I look at I to the third should be I squared times I, which is -1 times I, which is -I. I to the fourth should be I squared times I squared. Right? But again, we said I squared is -1. So that's -1 times -1, which is 1. Okay, if I take it one more, I to the fifth, that's I to the fourth times I. But I to the fourth is 1. So that's just 1 times I. And what you know, okay, so that means every time we keep adding an I now, we're just going to repeat this pattern that we did over here. Right? I, -1, I, +1. Right? I, -1, I, +1. Right? Same thing. I to the ninth is I to the 10th is -1. I to the 11th is I to the 12th is 1. Now, the point of this is I want you to recognize the pattern, which is, for example, every time you raise I to a power which is divisible by 4, it equals 1. I to the 4th, I to the 8th, I to the 12th. If I said, what's I to the 16th? You would just say, it's 1. I don't need to keep doing this, right? It's going to be every multiple of 4 power has to be 1. If I have I raised to even powers that are not divisible by 4, like I squared, I to the 6th, I to the 10th, every one is -1. So if I said, what is I to the 30th? Okay, let's see. It's even. It's not divisible by 4, -1. Right? Just follow the pattern. I know that if I have, let's say, I to the 5th and I to the 9th, that's 1 more than a multiple of 4. And it's I. Right? 1, 5, 9. If your exponent is 1 more than the multiple of 4, it'll be I. So if I said, what is I to the 61st? Okay, well, 60 is a multiple of 4. 61 is 1 more. It's I. So you just try to follow the pattern. It will repeat itself. These 4 in this pattern forever. And that seems to be the point of them giving us these problems.